Next we will try to understand types of modulation. Okay, so types of modulation. Under this heading, the first one is amplitude modulation. Okay, see, we have the definition of generalized definition of modulation. It is a process in which characteristic of high frequency signal is changed in accordance with the original signal. So high frequency signal will be a carrier wave, original signal will be an audio frequency. Now what characteristics of high frequency carrier wave is changed, and that specifies the name of that particular modulation. So from the name itself we can understand that we are going to change the amplitude of the high frequency signal corresponds to in accordance with the original signal. Okay, so what we will do is I will write the definition of amplitude modulation. In this modulation, amplitude of high frequency carrier wave is changed in accordance with the original signal, keeping its frequency constant. Okay, so in amplitude modulation what we are going to do is we will change the amplitude of the high frequency signal, high frequency carrier wave, in accordance with the original signal but keeping its frequency constant. So let us try to understand by graphical representation. Okay, so see, this is the original signal, a low frequency audio signal. Okay, low frequency audio signal. This is time period and this is the amplitude. We specify it as V. Okay, so this is your original signal. Okay, and then we have a high frequency carrier wave. Okay, a high frequency carrier wave, and we have to modulate this two, that is mix these two signals. This is time period, this is V. Okay, so this is high frequency carrier wave. Okay, high frequency carrier wave, and then we have to modulate. And what is the modulation process? We have to change the amplitude of the high frequency carrier wave in accordance with the original signal. Okay, so the modulated wave for amplitude modulation will look like this. Okay, see, the waveform will look, the modulated waveform will look like this. We are keeping the frequency constant but we are changing the amplitude. Okay, we are changing the amplitude. Now see, let us represent this as different points: A, B, C, D, E, F, and this is G. Okay, what you can see from the diagram is at A, C, E, G, at this point the amplitude is 0. Okay, so if the amplitude is 0, the amplitude for carrier frequency should be kept same. Okay, at B and F it is at positive peak, so the amplitude has to be increased. At D it is at negative peak. To represent negative peak, the amplitude has to be decreased. So that is what we have done. So this is the point A, okay, where the amplitude of the high frequency carrier wave is remain as it is. This is the point at which the amplitude increases. This point is B, okay, positive peak. Again the amplitude is constant. This is point C. Then the amplitude starts decreasing, okay. So this is the point. This is the point where you get this is B, this is C, this is D, again E, this is F, and this is G, okay. So this is how you change the amplitude of the high frequency carrier wave in accordance with the signal, but we keep the frequency constant, okay. So this is called as modulated wave. So this is amplitude modulation. In this modulation, amplitude of the high frequency carrier wave is changed in accordance with the original signal, keeping its frequency constant. You just have to remember this definition and you have to represent it graphically, okay. So this is amplitude modulation. Let us now try to understand the next type of modulation, that is frequency modulation, okay. So that is what is called as FM, frequency modulation. So the second type is frequency modulation. So now you can guess, okay, what exactly we mean by frequency modulation, what we are going to change now. What we have to change? Characteristics of the high frequency carrier wave in accordance with the original signal. So what characteristics of high frequency carrier wave we are going to change? We will now change the frequency of the high frequency carrier wave in accordance with the original signal, keeping its amplitude constant. So that's it, okay. So in this modulation, frequency of high frequency carrier wave is changed in accordance with the original signal, keeping its amplitude constant, okay. So that is the definition of frequency modulation. Again we will represent it by graphically. So say this is the low frequency, this is the low frequency signal, your original signal. Say this is your high frequency carrier wave, which has to be modulated in accordance with the original signal. And the third one of course will be the modulated wave, okay. So in modulated wave, again let this point be A, this is B, this is C, this is D, this is E, this is F, and this is G. So at point A, C, E, G, the amplitude is 0. So the frequency remains same. At B and F, positive peak, the frequency increases. When you say frequency increases, F is equal to 1 upon T, right? They are inversely proportional. F is equal to 1 upon T, T is equal to 1 upon F. If frequency increases, time period decreases. So we have to, when we say frequency increases, we will show by the narrow waveforms. That means time period decreases. And at point D, that is at negative peak, the negative peak, we have to decrease the frequency. That means time period will increase. We have to indicate broad signals, okay. So that is what we will do here. So at A, the frequency remains same, and when it reaches B, we have to represent it by narrow pulse. Then at C the frequency again becomes same. Then at D it will be shown as broad pulse. Then at E again the original frequency. Then at F again the frequency should be increases, time period will be decreased, and then at G it will be its original frequency. So we have kept the amplitude constant. At A the frequency is same, at B frequency increases, C again it becomes same, at D the frequency is decreased, that means time period will increase, at E again it becomes constant, E, F the frequency will again increases because of the positive peak, and at G it will again come to constant. So this is your high frequency carrier wave, and this is the modulated wave. So this is frequency modulation. In this modulation, frequency of the high frequency carrier wave is changed in accordance with the original signal, keeping its amplitude constant, and this is the graphical representation of frequency modulation. The third one under the heading types of modulation is phase modulation. Okay, so now you have already got the idea. So what we are going to change is we will change the phase of the high frequency carrier wave in accordance with the original signal, keeping it amplitude and frequency both constant. Okay, so any positive change will represented by lagging signal, and any negative waveform will represented by leading signal. Okay, so I will just explain you what exactly mean by lagging and leading. Okay, in this modulation, phase of high frequency carrier wave is changed in accordance with the original signal, keeping its amplitude and frequency constant. Okay, so this is the basic definition for phase modulation. And say graphical representation. So this is a original signal, low frequency, here original signal, low frequency signal, low frequency original, low frequency signal. Okay, this is V, that is amplitude with respect to time. Okay, this is the high frequency carrier wave 1. Okay, so this is your high frequency carrier wave, and then the modulated wave. Okay, so the modulated wave will be like this. Okay, we have to keep the amplitude and frequency constant, but when we go from positive to negative, the phase should lag, and when we go from negative to positive, the phase should lead. I will just let you know what exactly you mean by that. We are keeping the amplitude and frequency constant. We are just changing the phase. Okay, this is V. So here we have changed the phase, this point we have changed the phase here it is lagging. Okay, so this is lagging phase shift. I have explained you things with respect to the phase shift in CRO. I have explained you what exactly we mean by leading phase shift and lagging phase shift. Leading by 90 degree, lagging by 90 degree. So this is lagging and this is leading. Here we are going from positive to negative, so it is lagging. Here we are going from negative to positive, so it is leading phase shift. So we are changing the phase shift, but we keep the amplitude and frequency constant. So that type of modulation is called as phase modulation. So in this topic, under the heading modulation and types of modulation, you need to remember the definition of modulation, the necessity of modulation, and the type of modulation, just the definition and the graphical representation. So this entire topic is covered for your board exam. Okay, so this is all about modulation in modern electronic communication. I hope you have understood. So now if somebody asked you what exactly 93.5 megahertz, so 93.5 megahertz is nothing but the carrier wave. It's not the original signal, it's the carrier wave where the characteristics of the original wave has been mixed, and when it reaches to you, you demodulate the signal. Okay, demodulate the signal. You separate the high frequency carrier wave and the original signal. Then we don't use the high frequency carrier wave, you just use the original signal, give it to the amplifier to amplify, and then it will be given to the speaker so that you can listen to the original signal. So now I think the idea about modulation is clear to you. Thank you.